One of the most controversial questions regarding the structures that make up polygonal complexes is the question of their purpose. This alone gives reason for reflection. A similar question applies to many ancient structures, including those made from rubble stone bound with mortar. Among them, there are certainly some highly enigmatic ones, such as Picolacta, Chanquillo, Cuilap, or, for example, the perforated road. However, most ancient structures can still be linked to specific cultures. Based on material remains, architectural features, and location, it is usually possible to hypothesize their intended function. Was it a workshop or a complex with fortification purposes? Was it a livestock enclosure or some kind of storage facility for food, ammunition, or weapons? Was it a residential structure or a place for religious rituals, ceremonies, and so on? The same applies to a number of structures within polygonal complexes that were later built using unworked stone. With structures made from polygonal masonry, things are more complicated. Many of them have construction features and details that leave us with no direct comparisons. In any of our buildings, all structural elements, regardless of the building's purpose, are well identified, and their function is clear. The roof provides protection from precipitation or sunlight. Walls serve as a supporting structure while also shielding against rain, wind, and the sun. The floor, doorways, and window openings all have understandable functions. However, in polygonal structures, there are inconsistencies in nearly every one of these aspects. There are no roofs. We would not build all structures without roofs in a mountainous region with tropical rains. Yet for polygonal structures, roofs were not provided. Reconstructions depicting these buildings with roofs are pure speculation. In some cases, coverings did exist, and special blocks were even made for this purpose. However, these coverings were placed over walls, while the interior space of the structures remained open. Something similar, made of roughly worked stone, clay, and reeds, can occasionally be found among indigenous constructions. But since the Incas still preferred to cover their buildings, this is clearly an imitation of elements found in polygonal structures, just like the trapezoidal niches in their constructions, or the protruding steps in mortar-bound masonry. In polygonal structures, outcrops of bedrock often protrude from the floor, or the entire floor itself may be part of a rock formation. Trapezoidal niches are inconvenient and impractical for everyday use. Window openings are often absent altogether. Doorways show no traces of door fastenings, and due to their trapezoidal shape, they are equally impractical. That leaves only the walls. But in this case, they do not serve a supporting function. There is nothing for them to support. This leaves only one possibility: walls as a medium for placing polygonal elements, niches, and bosses, or for creating macro-level configurations. It is impossible to determine the reasons behind many specific design choices in polygonal structures. For example, why were the rear sides of the 6 megaliths in Ollantaytambo, as well as the rear sides of the blocks of the structure in front of them, covered with small polygonal blocks? It seems that this was done to adjust the overall thickness of the wall for some reason. These megaliths are essentially the facade of the platform's cladding, but in all other claddings, the rear side was not even processed. It was simply embedded into the embankment. It is also unclear why, in Machu Picchu, a cavity in the rock, which became the first level of the tower, was lined from the inside with polygonal masonry. As a means of providing strength and stability to the structure, it is useless. The rock base is unlikely to require additional reinforcement. Even more so, it made no sense to create it with details that are traditionally considered special elements for securing roofs, since a roof in this location would be entirely unnecessary, and the very use of polygonal masonry here must have had serious reasons, because placing blocks in a confined space would have inevitably introduced a whole range of additional challenges. Similar challenges must have arisen during the construction of sections of masonry with mirror symmetry. This also applies to the fact that many bosses, traditionally interpreted as remnants of lifting grips from quarrying, are often finished with great care. Such refinement could not have occurred as a byproduct of quarrying block blanks. It is clearly the result of deliberate action. Even more questions arise regarding some of the most enigmatic elements on polygonal blocks, the so-called nipple-like protrusions. Obviously, their creation required considerable effort and significantly altered the appearance of the block's front surface. Yet, the rationale for investing resources into their production remains unclear. And so on. There are plenty of similar examples, many of which have been discussed in detail in previous videos. Many of these solutions seem irrational or even completely inexplicable. Many appear unnecessarily labor-intensive. However, it is clear that all of this was done deliberately. And since such choices were made, and significant effort was invested, it means that something very specific was being achieved, something that could not have been accomplished by other means. At the same time, this issue is not limited to just specific technological aspects that seem unnecessary or meaningless. The polygonal masonry technique itself, particularly with curvilinear joints, is unlikely to be of any practical use to us today. Its primary advantages are said to be strength and stability. But we can achieve the same results using other methods that are far more effective, convenient, and accessible to us. We can easily replicate the appearance of polygonal masonry, the look of the polygonal block's front faces. However, such an imitation would serve only the function we assign to it, decorative. In authentic polygonal masonry, its external appearance was inherently dictated by a whole set of necessary technological processes, without which it simply would not exist. There are numerous reasons why determining the purpose of such structures is challenging. The first, and most obvious, is the loss of historical context. We have structures built using polygonal technology, but the circumstances surrounding their creation have dissolved over time. The context has vanished. This is an objective reality. It does not require additional proof. At the same time, the role that context might have played in this case is quite clear. It could have supported, supplemented, or reinforced the functional aspects of objects within polygonal complexes. It could have given them an active purpose. In other words, it could have made them functional, given meaning to both their creation and their existence. And if one day we manage to identify at least the key aspects of this lost context, it is possible that the reasons behind the use of such an unusual stone cutting and construction technique for creating such strange structures with enigmatic functions will become clearer. Determining exactly what this context represented is no simple task. Questions about the origins of polygonal technology, its technical nuances, its authorship, and, in turn, the purpose of these structures remain unanswered within the framework of what is known about past civilizations of South America. The products of polygonal technology are not linked to the civilizational, cultural, sociological, economic, or technological background of the time and place to which they are traditionally attributed. Moreover, these structures are poorly suited to human physiology. Where indigenous people modified polygonal structures to adapt them to their needs, this becomes especially evident. The first things they added to polygonal structures were roofs, then partition walls, and so on, everything that makes a building suitable for human habitation. Modern researchers did exactly the same thing in Machu Picchu not so long ago. And this is not a coincidence. Before these modifications, such structures were buildings with designs unsuited to human needs and with functions that did not manifest themselves in relation to human use. As we can see, the answer is not obvious. Perhaps it lies deeper, in knowledge that is extremely difficult to comprehend, or, as is sometimes claimed, even forbidden. However, a brief analysis suggests that the answer may also be found among everything we consider self-evident. Among things that are rarely examined in detail due to their complete and unquestioned obviousness in the realm of data that people use by default. Indeed, in this realm, we find many fundamental aspects related to the technology that allowed the creation of polygonal structures. For example, the assertion that all such structures are in some way related to stone belongs to this category. The fact that they are made in stone and from stone is so obvious that, by the right of absolute obviousness, it automatically, along with many accompanying details, falls into the category of default knowledge. This frees up attention, allowing it to be focused on other unquestionably important specific aspects, such as identifying types of stone, the circumstances of its extraction, processing, and so on everything directly related to the practical realization of such structures, since that is what interests us the most. Stone truly appears as the foundation of foundations, both literally and figuratively. The most suitable epithets for it here are stability, solidity, permanence, and fundamentality. It appears in the form of mountain slopes and rock outcrops, which were used as the base for polygonal structures. It appears as rocky slopes, individual boulders, and stones that served as the basis for strictly typified cutouts for the creation of channels and drains necessary for water flow regulation. It appears in the form of polygonal blocks, whose use allowed for the construction of large and complex stone structures of various configurations. And also in the form of small, individual objects whose purpose and method of manufacture raise the same unanswered questions. The functions of stone in relation to the structures we are interested in are also diverse. It serves as the primary material for buildings, for polygonal blocks, for cutouts, for small objects. At the same time, it is also their face. It is the medium in which water flows are placed and simultaneously one of the means of their regulation. It is the medium where configured cutouts are based. In short, stone, possessing the properties of one of the aggregate states of matter, provides the conditions and, to some extent, sets the parameters for what is created upon its foundation. And this is far from the full list of things related to this topic that, by the right of absolute obviousness, belong to the realm of default knowledge. However, even at this stage, a few points emerge that are worth closer examination. The most important among them seems to be this. Whenever a property of stone is mentioned, it is accompanied by a mention of what this property affects. This is natural, because the properties of stone, like those of anything else, always manifest in relation to something specific, a kind of universal quantization. At the same time, the added components that supplement the natural foundation are made of the same material, stone, but they are specifically made. This is a common trait among all of them. They are all artificially created. Polygonal blocks, water channel beds, cutouts in rock outcrops and boulders, embankment structures, and many other things of this category are all components that supplement the natural foundation, and all of them are elements that have undergone prior deliberate processing and preparation. That is, objects created using polygonal technology consist of multiple components, the natural stone foundation, and added, specially manufactured elements. This principle of organization can be traced in all cases, and it can be classified as fundamental. This is also completely obvious and also belongs to the realm of default knowledge. However, attention has been drawn to this particular point for a reason. Here, something emerges that is not so obvious and indisputable. The fact is that in objects created using polygonal technology, besides the natural foundation and artificial components, such as blocks, megaliths, cutouts, and embankments, there is always another category of artificially formed elements. Some of them, like water flow, are visible to the naked eye. For others, such as configured cutouts, additional justification is required. Nevertheless, they share several intriguing common features, and the first and most significant for us is this: they are not made of stone. In other words, the thesis made from stone and in stone does not apply to them. This is something different, something that the object itself, created using polygonal technology, highlights in its surroundings and formats in a specific way. If we were to seek an analogy, however distant, with something we use today, we might, with some reservations, compare it to the draft in a stove. Clearly, the presence of this element is a condition for the proper functioning of the stove. Without it, which could occur for a variety of reasons, the stove immediately becomes an object that no longer fulfills its primary function. It becomes a hollow shell. And this, despite the obvious relativity and simplification of all analogies, strongly resembles the situation with the question of the purpose of polygonal structures in our case. It is quite typical for structures created using polygonal technology to be perceived solely as constructions where a stone foundation is supplemented with artificially created stone elements, megaliths, polygonal blocks, stone, and earthen embankments. However, if we turn our attention to water channels, for example, we see that the parameters of the water flow within them, its speed, volume, and even its spatial configuration, are always precisely formatted. In other words, the water flow within these structures is unquestionably artificially organized and subject to specific requirements. And as we know, water is not stone. It belongs to a different element, a different state of matter, liquid. Together with the natural foundation and the means that give the flow its required format, such as channels and drains, they form a single entity, a hydraulic structure. If we examine, for instance, the water channel in Cumbe Mayo, which has preserved many intriguing and, most importantly, authentic details, it becomes evident that the nuances of such a structure often extend beyond the mere task of water transportation. Although traditionally this has been considered the only possible and acceptable purpose, everything about the spatial configuration of this channel suggests that shaping the flow's form was a primary concern for those who built it. This is most evident in sections where the channel cuts through exposed rock formations. In many places, the upper edge of the rock foundation remains uneven, left in its natural state. However, the sidewalls have been leveled, not only where the flow directly passes, but also in areas where, due to natural irregularities, the walls are fragmented rather than continuous. There are also several locations where the channel's cutouts in the rock foundation follow curved arcs and stepped turns. These sections are closely arranged and essentially form interconnected compositions, meaning they can be regarded as independent functional elements. It is also noteworthy that even where the channel bends along an arc or makes a sharp turn, its width remains consistent, and the quality of the surface finishing in the curved sections is maintained. In some places, the channel's excavation within the rock is even more complex. Its path is carved not only downward, but also sideways into the rock mass, creating overhanging sections above the flow. Furthermore, approximately halfway along its course, the channel deviates toward a small rock located slightly off its main path. Instead of flowing around it, the watercourse penetrates directly into the rock through a specially cut passage. Inside, it makes a sharp 90-degree turn before emerging again and returning to its original direction. Even considering only these observed details, it becomes clear that the design of this channel extends far beyond the mere function of transporting water from one point to another. Therefore, its true characterization must take these nuances into account. A more precise description of the channel would be: it is a structure created on a foundation of rock outcrops, incorporating a formatted element in the form of a water flow, which has been given a specific configuration through cutouts made with particular parameters. The cutouts in the rock foundation serve as a means of imparting specific properties and configurations to the flow. As we can see, Part of this definition was previously contained within the realm of default knowledge. It was placed there in full accordance with Occam's razor. Entities should not be multiplied beyond necessity. In this case, as we see, necessity exists. Although water channels have been repeatedly modernized over the centuries, design solutions similar to those in Cumbe Mayo can also be found in Tipon and Machu Picchu, where water drainage channels exhibit similarly intricate configurations. The turning of the water channel near the tower likely belongs to this same category. We see the same organizational principle applied directly to configurations. The base material for the cutouts remains the same, stone, in the form of rock outcrops and individual boulders. Configured cutouts in this case also serve as a means of creating a necessary active element. Here, that element is the spatial configuration formed in the stone foundation through a combination of horizontal and vertical surfaces. Various types of stone are suitable for such structures. Different surface qualities are also acceptable. Cutouts are often found on rock surfaces with significant cavities and voids that were likely present before the cutouts were made. The surfaces may be precisely finished or roughly executed. The configuration is formed in either case, and its type is easily recognizable. Each type of cutout defines its own format of enclosed space. One horizontal and 3 adjoining vertical surfaces create a configuration that most closely resembles a seat. If such a cutout is located at the edge of a rock foundation or on a small stone, the third vertical surface was achieved by leaving a sidewall intact. No other reason for preserving it is apparent. Step-like configurations could be created in 2 ways. In one case, they were formed by a cutout with 1 horizontal and 1 vertical surface. In the other, 2 vertical surfaces adjoined a single horizontal one. These 2 variations are usually found separately, but some structures feature both together, forming a unified and original composition. Examples can be seen in the cave at Cuenco in Pumacocha and at the entrance to the lower section of the tower in Machu Picchu. Another type of configuration was created by shaping an overhanging slope. There are 2 such cases near the tower in Machu Picchu. A rock next to the tower also has an artificially shaped slope. Cutouts consisting of flat horizontal surfaces and curved vertical ones produced fluid, plastic configurations, including fully enclosed contours. 2 horizontal and 3 vertical surfaces create a niche-like configuration, either trapezoidal or rectangular. The depth of these niches into the rock varies. Regarding traditional theories about the origins of such cutouts, the quarrying hypothesis is not supported by factual evidence. Cutouts cannot be traces of material extraction for polygonal blocks. For freeform blocks, their outlines are too precise. In cutouts resembling niches, it would have been impossible to separate the rear wall of the extracted block using simple tools. The extracted material itself also seems irrelevant to the creators, as demonstrated by the cutout in Cuenco, a single 6-meter monolithic block with a curve and an extremely thin side. Similarly, material could not have been removed as a whole block from the niche in Sacsayhuaman. Sites with significant rock defects would also have been unsuitable for material extraction. There is indirect evidence as well. The quarry in Machu Picchu, from which granite was sourced for polygonal structures, is located within the complex, yet it lacks any configured cutouts or the typical lifting bosses seen in worked stone. At the same time, the complex itself contains numerous configured cutouts, but these are harmonious elements of finished structures. Furthermore, the shape of these cutouts and their grouping reflect certain nuances of their creation. This also contradicts the quarrying theory. It is evident that surfaces at the same level are fragments of a single surface left after additional cutouts of different configurations were applied. Such multiple extractions, performed in an uneven manner with varying volumes and proportions, do not align with the process of obtaining block blanks. Neither the utilitarian nor the ritualistic hypothesis adequately explains the existence of configured cutouts. If they were created for such purposes, their shapes, sizes, and arrangements would not be so highly variable. They would not be located in areas with cracks and fractures when flawless rock is available within arm's reach. Niches, if they were meant for religious, social, or practical storage purposes, would be far more common, yet they are surprisingly rare. On the other hand, interconnected complexes consisting of numerous seat-like and step-like cutouts in various arrangements are encountered regularly. There are also exceptional cases where configured cutouts cover the stone foundations so densely and compactly that it takes on the appearance of a unified object. Intihuatanas are the most well-known examples of such formations, but similar cases include the carved stone of Sehuite and many other rocks and stones shaped in this manner. The same organizational principle is evident in structures built using polygonal masonry. The foundation remains the same: rock outcrops and mountain slopes. As components forming the active element, we see embankment structures clad in polygonal blocks, along with the polygonal masonry itself. Polygonal masonry is the key feature of such structures. The interlocking of blocks through curved contact surfaces ensures their integrity. It also eliminates the need for binding materials, making the masonry homogeneous. Combined with additional measures, such as tilting towards the foundation, embedding the rear sides of blocks into the embankment, and reinforcing corners, this masonry was fully capable of providing the necessary strength and stability to the structure. As for the active element formed by these structures, the configurations of polygonal masonry structures correspond to the same types as those found in configured cutouts: seats, steps, and plastic forms. Essentially, polygonal structures are adaptations of the same principle applied at a different scale. The only differences are in certain aspects of placement and the frequency of use of the niche and seat types. This topic was specifically addressed in the third episode of the series, Traces of Alien Technologies. It is also worth noting that among structures built with polygonal masonry, several distinct groups can be identified, each with varying levels of complexity. The simplest type consists of a rock outcrop encased in a polygonal shell. Such structures are easily recognizable, as their organizational principle remains unchanged, even though they never exactly replicate each other. For example, in Tambomache and Pisac, the configuration of the rock core has been modified, and polygonal masonry nearly fully envelops it. The masonry adheres so closely to the rock foundation that it almost merges with it. In Cuenco, we see a different approach. The rock outcrop was used in its natural form. Polygonal masonry covers the rock only up to a certain level, leaving a gap between them, which is filled with soil and rubble. At this stage, the organization of structures is still based on utilizing the potential of the rock foundation. In Pisac, for instance, the volume of the rock itself allowed for the creation of much of the structure. However, significant modifications were also made. Material shortages were compensated for in necessary areas by adding individual polygonal block elements. Where the configuration could be achieved without polygonal masonry, excess material was simply removed. The same technique can be observed in the tower at Machu Picchu. Excess material was removed, and where needed, its absence was compensated by polygonal block constructions. Structures built on mountain slopes, terrace-like platforms, required much more significant modifications to the shape of the foundation. This was achieved using embankment structures. Previous videos have provided ample evidence that such structures were not designed for agricultural or fortification purposes. Terrace-like platforms are essentially large-scale configurations of seats, steps, and plastic forms, analogous to configured cutouts in stone but on a greater scale. At the next level, within polygonal complexes, the proportion of structures built entirely with polygonal masonry increases significantly. Many structures are constructed entirely from polygonal blocks, with foundations that may be rocky, embankment-based, or mixed. In addition to these, polygonal complexes include other types of structures: terrace-like platforms, rock outcrops with configured cutouts, structures combining rock cores with embankments clad in polygonal blocks. The presence and combination of these elements vary greatly. Polygonal complexes never replicate each other exactly. It is also possible that many individual polygonal complexes, hydraulic structures, and configured cutout complexes may have formed a unified system. This aligns, at least in part, with the way the Incas viewed these complexes as elements of an extensive interconnected system with its center in Cusco. As we can see, structures built using polygonal masonry can be arranged in a sequence of increasing complexity and scale. In doing so, a particular pattern becomes evident. While the structures grow progressively more complex, all the fundamental conditions of their creation, such as curved interlocking joints and mortar-free masonry, remain unchanged. Despite the exponential increase in the number of blocks required for their construction, each block continues to be crafted individually. In other words, the organizational type remains the same across all levels of complexity. The changes that contribute to increasing structural complexity are limited to adjustments in scale and proportions. The differences between structures at different levels arise from variations in the combination and proportion of the same fundamental elements. Put simply, the increasing complexity of structures in this sequence is not caused by changes in construction technology, nor is it accompanied by them. No technological evolution is observed. There is no transition to orthogonal masonry, standardization of block shapes and sizes, or the use of binding mortar, even though these would have significantly accelerated and simplified construction. This suggests that throughout the entire period of construction, all fundamental aspects, both methods and materials, remained unchanged. Yet the result was consistently satisfactory. This indicates that the structures fulfilled the purpose for which they were created. The absence of a transition to other construction technologies suggests that alternative methods would not have been able to achieve the required result. Such transformations occurring from level to level cannot be classified as evolutionary. Nothing here evolves. On the one hand, this makes it difficult to determine the sequence in which the structures within polygonal complexes were built. On the other hand, it suggests that all of them, regardless of their level of complexity, were created as individual parts of a unified whole. Moreover, they were likely built either simultaneously or within a very short period. This, in turn, may indicate their specialized nature. The observation that artificially created components appear to belong to the earth element, while the elements they form seem to be associated with other elements, may tempt one to draw parallels with ancient cosmological concepts. These are the ideas where earth, water, air, and fire serve as the fundamental components of all existence. However, there is insufficient justification for making such comparisons. One could indeed categorize everything used to create the necessary configurations as belonging to the earth element. This includes the formatted rock foundation, boulders with cutouts, embankment platforms, polygonal blocks, and megaliths. The definition, made of stone and in stone, is entirely accurate for this category of objects. Water flows, formatted through stone-based means and hydraulic structures, would naturally belong to the water element. However, identifying components that could be clearly attributed to the air element is much more difficult. Certain types of cutouts might be considered in this regard. For example, one could focus on the acoustic properties noted in niche-like configurations. but applying the same reasoning to other configuration types is problematic. Viewing them from this perspective is a stretch at best, no more or less valid than applying it to any other material object with shape and volume. Attributing anything to the fire element is even more challenging. For example, there are accounts of glowing columns above the Intihuatana in Machu Picchu, but assessing their reliability or regularity is difficult. The same applies to the many vitrification traces resembling signs of melting. No systematic study has been conducted on them. The same is true for the magnetic anomalies observed in andesite blocks at Pumapunku, and for traces on blocks and megaliths that resemble signs of thermal exposure. Not only can each of these phenomena be classified as manifestations of the fire element, only with great difficulty, but they also require further confirmation and systematic investigation. Additionally, there may be other similar manifestations that have gone unnoticed, simply because they are not immediately visible and thus remain unknown or little studied. As we can see, within the realm of default knowledge, there truly exist aspects of these objects that had previously been overlooked due to their apparent obviousness, or had been interpreted solely within the framework of current academic priorities. Outside this realm, only the objects themselves, polygonal structures, remained simply by virtue of their physical presence. Consequently, all related questions about the technical nuances of their creation also remained outside this realm. This is likely the key to understanding why the purpose of such objects remains so difficult to determine. The domain in which these structures were functionally active only partially overlaps with the domain of our interests. They intersect, but only at those specific points where we directly associate them with their physical presence in the landscape. Everything else, including the details of their functions, remains beyond our perception. The product these structures generated is not something we recognize, simply because aspects of natural phenomena that could be the result of polygonal objects lie beyond what is necessary or relevant to us. It is possible that we walk over them, perhaps even in the most literal sense, but they do not register as products for us. They do not fit within our system of priorities. In conclusion, summarizing all the above, we can infer that solving the question of the purpose of objects created with polygonal technology cannot be complete and sufficient if limited only to studying the nuances of polygonal technology itself. It seems that the discussion here must extend to a technology of a higher order than polygonal construction. Most likely, it is a technology aimed at creating and maintaining an operational environment with specific properties and predefined parameters, through configurations formed by water flows, configured cutouts, and structures based on polygonal masonry. Polygonal technology, despite its complexity and labor intensity, in this case appears to be merely one of its components. It is a specific practical application, focused on directly materializing these configurations in the landscape.